What's up? We're doing the abstraction part, so go to your PT survival guide, and we are looking at the abstraction portion. Let's get into it. Is it a good abstraction? So what is abstraction? We define it as multiple levels of abstractions are used to, not define it, but this is what they're looking for. Multiple levels of abstraction are used to write the program. The process of developing an abstraction involves removing detail and generalizing functionality, and students use abstraction to manage complexity. Okay, so remember, complexity means the longer your code is, the more complex it is. If you have something that's repeating, or you need to use multiple times, then writing a function for it and calling it multiple times later would manage your complexity for your program, instead of having to write that part out over and over and over again. So we saw this if you were drawing a star, for example. You could write a program that makes like a cone or an arrow, and then instead of having to do that 5 times for the star, you just write one program that writes that triangle and call it, or cone, whatever it is, and say function cone, and then you could have a subprogram that makes all the 5 cones draw it. So draw the cone 5 times. So that's what it's looking for, something like that. Now we're not going to be drawing. This is not a drawing program. Your program has to be something that does something, so it's going to look a little different. Okay, so abstraction manages complexity. Programming abstraction makes it easier to write complex programs. The API is checking that you can create, identify, and describe an abstraction that manages complexity. Alright, so it has to be something that you wrote yourself. It can't be something that your partner or someone else helped you with. It should be a function. So we're looking for a function. It should start out with my function or a function, and it demonstrates complexity. Basically, it should call something else that you created as well. Would be ideal. So it gets called from multiple different places in your code. So if you made a function, it gets called multiple times. If it just gets called once, it doesn't really manage complexity, because then you could have just wrote it. That's it. It has a parameter that generalizes some behavior. So a parameter would be really cool, because you could use it for different things and different steps. Bad abstraction. Don't use on events. On events are not a good example, because on events, they're already provided to you. They have a set way of doing things. It just tells you to do something when you hit a button or something like that. So don't do those. I guess that's the main way that you kids lose points. I don't think I had anyone do that last year. Variables by themselves are not abstractions. Yeah. Okay. Logical loops and stuff like that aren't aimed as well. We want to look for a function. Okay, so it doesn't count. So this is the criteria that they're looking for. Select code segment is student developed abstraction. So you're going to box a piece of code that is abstraction. So responses that use existing abstraction create a new abstraction, such as creating a list to represent a collection, would earn this point. Do not reward if the existing abstractions, such as variables, existing code structure, event handler APIs. So that'd be like on event. Don't use that. The code segment consists of abstraction is not included in the written response section or implicitly identified. So you didn't talk about it in your written response, or you didn't show it in your code that you PDF and showed them. Or the abstraction is not explicitly identified, i.e. the entire program is selected as an abstraction without explicitly identifying. You've got to make sure we put our box only around the part that has to do with the student developed abstraction. So don't do it around your entire 200 lines of code. Okay, so the following are examples of abstraction: procedures, parameters, lists, APIs, libraries, lists, and other collections. Kind of confusing here. That's why we have an example, and we're going to evaluate if it earns the point. So would we give it the point for row 7? Why or why not? And does it manage complexity? Alright, so let's look at the first two. So what do we have? We have an on event where you click the button, it sets the text, sets the property, and it shows an element. Is this abstraction? No, it's not. First of all, it's not a function. Remember, we said on event is a no-go. So this is just an on event. No. Doesn't manage complexity, not at all. Nothing in here. These are all set APIs that they give us. So we didn't make anything, and it doesn't really save us any time. Okay? Next one, on event, button 1, click. function event if the score is less than 0. So we have a loop here. If it's less than 0, then do this. Okay. Still, it's an on event. It's not a function. You've not created a function. Now, whatever the game over screen is, or sorry, set screen function, that seems like it is maybe a function that you made, but it's just one from API, so that doesn't work either. Okay, let's look at their answers. So, no, not student developed. On events do not count. The algorithm is a series of pre-existing functions. So yeah, don't do that. No, code is a single space. Not, again, same thing here. It's just on event, doesn't count. No code. Code would only be used in a single portion. Again, a single event handler, bad choice. So the first two. All right, 1 second. Okay, whoops. Showed you the wrong screen there. Here we go. All right, example 3. We have an on event again. Dangerous. But it has update player turn, update score. If the score is set screen, else update the board. So this one's interesting because we have an on event, but we do have update player turn, which is a function that someone would have made, and update score, which is a function, and update board. So those are all functions that someone made. Now they're not showing the functions. So this could be an example of it, but we don't see what the update player turn, update score, or update board is that should be included. So let's take a look at their answer. So no, the code identifying the rectangle doesn't show the student developed abstraction yet. So it doesn't show those functions, how they're made. Like, what is the update player turn look like? What's that function look like? If they showed that, then we would have had a student developed abstraction. But those weren't inside the rectangles. You don't get credit for them. So they would just look at the on event and say, nope, no soup for you. Okay. This may manage complexity, but the code in the rectangle does not. The student captured the wrong thing. So it could have been a really good one, but they captured the wrong part. Bummer. All right, let's do 4 and 5. So here we have an on event that calls a function. The function is developed by the student. So here we have a function. We know what it is, says. It's a student created one. Does it manage complexity though? Technically, yes. Yes, because set button props is a student developed abstraction. It is. They developed it and they called it later. Does it manage complexity? Probably not a good choice, especially the function is only called once from the event handler. So it's only called once here. We don't really have a good set or understanding if this is going to be used again or anything like that. So probably, but not a great example. Let's move on. Number 5. You notice they always get better. So example 6 is our last one. It's probably going to be the best one. Here we go. On event, so you click the button, it sets the button props and it shows that. And then on event, if you click something else, it also sets the button props. So now it's showing that's used twice, which would help manage complexity. And we also have a student generated one. So this might be a yes, but I don't know. Yeah. Oh, it says no? Okay. This one is tricky because they put the box around the wrong part. So the code in the rectangle does contain a student developed abstraction. This part is the student developed, the function. The student may have been attempting to show that how it managed complexity by including 2 different places in the code that it calls it, but a harsh reader say no because the on-event handlers are not student developed. So you want to show the rectangle around the student developed part, but you still want to also show the code uses it in other places. So if they put the thing in the right box, it would have been good. If identified correctly, set button props is a good choice since the function is called from several different places. So this would have been perfect if the red box was just around the set function, but it's not. So that's an iffy one. Alright, so here you can see this one. They have a function they created. The red box is around, only that. It's used twice with parameters. Parameters are good. If you can use parameters, awesome. That really shows that you're using abstraction here. And you're also managing your complexity. So this one should be a yes, yes. So the student developed abstractions here. They create a function that they call twice. That's great. They even use parameters to demonstrate how it manages complexity. This function is also strong because it has parameters, so parameter. If you can add those, that'd be great. So it's easy to show with a contrasting argument why not having a parameterized version of this function makes things more complex. So if we didn't have that parameter in there, it'd be hard to tell it how to update the score. You'd have to do update score if correct and update score if it's wrong or something like that. So this makes it way easier. So if you are picking a game like a clicker game or something like that, you already have a genius idea right here. Do a score. Have some game where you have a score that needs to be updated, and there you go. You can have your student-developed abstraction that manages complexity using parameters. Okay, that's it. So those are your ways of, hopefully you have a better understanding of the type of abstraction you need to make.